Alright, so for section 6.1, we're going to talk about general and particular solutions. Slope fields are also part of this, but I'm going to post a separate video for that. Alright, so first let's just kind of revisit what a differential equation is. So a differential equation involves variables x, y, and some kind of y prime. Okay, so a derivative of y. So just a generic example would be something like 2xy prime minus 3y equals 0. Okay, so that is an example of a differential equation. All right. And differential equations have solutions, and a solution of and I'm just going to abbreviate this to diffEq. If you take the course differential equations later, you'll understand that. So a solution of a differential equation exists when we have some function y that's equal to y, so some y equals f of x replaces y and y prime to satisfy the differential equation. Okay. And so let's look at an example here. So we'll say example 1. Y is equal to c e to the 6x. And we want to verify if that is a solution to the differential equation y prime is equal to 6y. Okay. So I'm going to calculate the derivative of this function of x here, this ce to the 6x, and then plug in y and y prime into my differential equation and just see if it satisfies that equation. Okay. So the derivative of y is, use the chain rule, 6ce to the 6x. All right. So now I'm going to substitute that in to my differential equation for y prime. All right, and then I'm going to plug in the original function for y, which is ce to the 6x. And as I can see, those are the same, so therefore I have a solution. Okay. All right, then when c can be any real number, it is called a general solution. Okay. So it is called a general solution. So no matter what I want to plug in for c, I will have a solution no matter what. Okay, and that's called a general solution. All right, but here, well, and just to clarify, this would be an example of a general solution because no matter what I plugged in for c, it's going to get multiplied by 6 when I do the derivative. When I plug it into the differential equation, then it's going to get multiplied by 6, and so therefore that is a general solution. All right. However, if a differential equation is given some kind of initial conditions, so if it's given some kind of initial condition, then it is a particular solution. Okay, so a general solution will satisfy any value of C, but if it is given conditions and it satisfies those conditions, then it is just called a particular solution. So let's look at an example of that. So let's say we have the differential equation, or excuse me, the general solution y equals CE to the negative 9x. Okay, so this is our general solution. We have the differential equation y prime plus 9y equals 0. So that's our differential equation. And our conditions are when x equals 0, then y equals 6. Okay, so those are our initial conditions. All right. So first, let's just check and make sure that that is a solution to the differential equation. So y prime would equal negative 9 CE to the negative 9x. So now I'm going to plug that into my differential equation. So I have negative 9 CE to the negative 9x plus 9 times my original CE to the negative 9x. And see if that equals 0. Of course it does. So that is a general solution. All right. But then utilizing the initial condition, all right, what I'm really looking at is to say, well, what is the function or the original function or the solution, I mean, not the original function, but the solution evaluated at the point 0, 6, right? Because when x is 0, y is 6. So I'm going to say 6 equals CE to the negative 9 times 0. All right. Which, as you can see, that's just e to the 0, which is 1. So 6 equals c. So my particular solution for this, to satisfy those conditions, would be that y equals 6e to the negative 9x. Okay, and so that would be the particular solution. Again, I will post a video, a separate video from Khan Academy talking about slope fields, just to kind of give you a little insight. We won't use slope fields in this course just because of the graphing being so specific that you need some form of technology. But I do at least want you to be able to look at those. So let me know if you have any questions, and as always, have a great rest of your day.